In this video, I'm going to show you how to expose an application running on your home network to the internet in a more secure manner, taking advantage of Cloudflare tunnel and single sign-on to secure the app itself, but also your entire infrastructure from sort of passers-by. So I'm going to go over the layout. So we've got our home network and the internet. And this squiggly blue line down the middle denotes the separation between our home network and the internet. So you can imagine your router is this line, and the IP address of my home network is 192.168.11.0. On my home network, I have an app that I want to make available. So that's running on a virtual machine with this IP address on port 9000. The way that this would traditionally be done is you would open a port on your router, and this would look something like this. We've got a domain name that we want to serve the app from. So I'm going to serve this from app.mybigballs.space, and I would then create a DNS record for that. So when a user goes to app.mybigballs.space, it will resolve that to my home IP address, which will then talk to my router. I would have to configure a port forward on my router to receive traffic on port 80 or 443 for HTTPS, and tell it that actually when it receives a packet like that on its WAN interface, it needs to forward that to my virtual machine on my local network side on port 9000. This is all great, it works, it's fine. What I don't like about this is I don't want to open any ports on my router. I don't want HTTP ports open for passers-by to start poking and prodding at. And I don't like having services running on my network associated with my internet traffic. So we're going to do this slightly differently. And this is how it's going to work with Cloudflare Tunnel. So keeping our web app where it is, we've got a domain, and we're gonna when a user visits this, they're gonna get a single sign-on prompt. So we're gonna use Google in this example. And once they've done a single sign-on, they go to Cloudflare, and Cloudflare is going to manage the ingress of traffic into our network with a separate virtual machine on our local network side that's running Cloudflare Tunnel. You don't need to forward any ports for this. Cloudflare Tunnel is essentially going to do NAT hole punching. So this works very similarly to things like Zero Tier, Tailscale, Hamachi. Essentially punching holes in the NAT provided by your router so that you don't have to configure any port forwards. What I like about this approach is we're going to configure on Cloudflare the users that are actually authorized to see this. So every user will be taken to a single sign-on prompt, and then that data is returned to Cloudflare after a login. And we can set a list of authorized users on Cloudflare. So essentially in this case it will be email addresses for the Google account. And if the email address is on the allowed list for the application, then their traffic will be sent onwards to the application. If they're not on the allowed list, then Cloudflare will display an error message to the user. This is great because a passerby would not be able to send a single packet to your web app. They would not be able to talk to it. And in this case, I'm going to use a really dumb static web app for this purpose, but this might be something that you're hosting on your network with a login. It might be a third-party application. It might be something like Overseer or Mealy, which are two applications that I host for external access. If I'm not keeping that app perfectly up to date, or if there's a zero-day exploit in that application that might allow a user to exploit it without logging into it, I don't want that exposed to the internet. Because I can't really guarantee that I will keep everything up to date on my network, and I don't really want that responsibility. So actually being able to shield the app entirely behind a single sign-on is exactly what I want. I think it's the best way of doing this. The only downside to this is essentially a double sign-in if you've got an application that requires authentication as well. So the first time a user visits the app, they will get prompted for a single sign-on via Google in this case. And then assuming that goes okay, they will then get forwarded to your app, which they might have to sign in again on the app itself. It's a minor inconvenience, I think, and you can set the time to live on Cloudflare for the SSO session, and that could be up to a month. So they'll only have to log in again every month on the SSO side. So it's really not too bad, I don't think. Right, I'm going to go through now some of the things that I've got set up in advance of this. The first is the app itself. This is the virtual machine 192.168.11.60, and this will be running my app. So I've got a folder on here, and I've got a simple Docker Compose file that will spawn Apache, and it's running my app on port 9000, so it's fairly self-explanatory. So I'm going to start that. And if we go to that IP in a web browser, then we can see that that is all working as we expect. The other things that you're going to need for this set up already is a Cloudflare account and log into that, and a domain name. So the domain name I'm bringing over, I've registered elsewhere for very cheap for the purposes of this video. This cost me about 99p, and I'm going to be moving this over to Cloudflare. You can, if you are buying a domain, do it through Cloudflare, which is a little bit easier, which means that you don't have to change any name servers elsewhere and have two different kind of locations where you're managing that domain name. And I think Cloudflare is quite reasonable for domain registration costs. So the first thing I'm going to do is add my domain name that I've registered elsewhere to Cloudflare. So I'm going to hit Manage Domains and add a site. And Cloudflare, this caught me just now. Which plan do I pick? It's the one that's kind of hidden down the bottom here. There's no charge for any of the stuff that we will be doing on Cloudflare. So we're going to select the free one. Oh, so that's going to bring in any existing DNS records that it has found. I'm actually going to delete that because I don't want the records that have come over from the domain registrar. So I'm just going to leave that as default. And Cloudflare is going to tell me my new name servers. So I'm going to copy the first one of those and go over to my registrar. And I'm going to paste these in. And now we wait. This should be pretty quick. You can hit the check name servers button on Cloudflare and we'll see if those have updated yet. This is time to probably go and get a coffee, to be honest. Cut forward to an amount of time later. We'll hit the check name servers button again. We'll refresh. And we've got the nice green tick here. Cloudflare is now protecting your site, which means that the DNS changes have propagated. So now we're going to set up the Cloudflare tunnel into our network. I'm going to hit back to go back to the main dashboard. I'm going to go to Zero Trust. And on here, I'm going to drop down network and select tunnels. And I'm going to create a tunnel. Leaving this as the default option there for Cloudflare D. Get a name, tunnel, can be anything. It'll save the tunnel, and it will give me a command to copy and paste into my tunnel machine. I think by default this is Windows. I'm going to change this to Debian, which should also work for any Debian-like distros like Ubuntu that you might be running. So I'm going to copy this, and I'm going to SSH into my tunnel VM. And paste in the command from Cloudflare. The virtual machine I'm using for this is just a plain Debian install. I think I gave it half a gig of RAM and one CPU core, 10 gig of storage space. It really doesn't require much power at all. So once that's done, if we go back to Cloudflare and hit tunnels, we can now see that we have a new tunnel and it is marked as healthy, which is great. We can then select the tunnel and hit configure. And then under public hostname, we can add a public hostname, and this is where we're going to set up our subdomain to point to our app. So we're going to go app.mybigballs.space, and I'm going to leave the path blank. And this is where we're telling it where it's forwarding this traffic to on our local network. So that is 192.168.11.60 port 9000. And we can save that hostname. Now, this should now be forwarded to our app. We haven't added any authentication yet, but if we go to app.mybigballs.space, we can now see our app, and this is live to the world. Now we need to secure our app, and to do this, we need to go to Settings, select Authentication, and under Login Methods, we need to add a new one. And these are all the different SSO providers or standards that you can use to authenticate a user. I'm going to go for Google. GitHub might also be a good option. Or you can use something like SAML if you wanted to integrate this with a more custom solution. So we'll select Google, and I'll go through this, but there are some instructions here on what you need to do. First of all, I'm just going to give this a name, which again can be anything. So we need to go to the Google Cloud Platform console, and we need to create a new project. Once that has created, keep an eye on this up here, we can select the project to go into it. We then need to go to APIs and services and select credentials. Then we need to hit configure consent screen. Use external. And we just need to give this some names here. This is actually a drop down, so you can just select the address of your Google account. And I think all of this is optional. Then we'll hit continue. We're going to add a scope, and we want to check userinfo.email, so that will make sure that the user's email address is passed from Google to Cloudflare, as Cloudflare will be doing the authorization part of this, so that will be deciding whether the user is allowed in or not. And save and continue. And we just need to make sure as well that your Google account is added to the test users. So put the add users button and add your Google account email address there. Once that's done, go back to OAuth consent screen, so hit this button and click Publish App. You now need to hit Credentials, Create Credentials, select OAuth Client ID. Application type is Web Application, and you can call this whatever you want. You now need to find your Cloudflare team domain. You would have set this when you signed up for Cloudflare Zero Trust, but you can find this by going to Settings, Custom Pages, and it will be displayed here. Back to Google, I'm going to add a URI for authorized JavaScript origins, and this will be HTTPS, your Cloudflare access domain. I'm going to do the same for authorized redirect URIs, which is the same, plus with cdn-cgi/access/fallback. This is copy and pastable from the instructions on here. If you go down here, I'm going to hit create. And this is going to give me some information that I need to paste back into Cloudflare. So the first one is the client ID, which on Cloudflare is referred to as the app ID, and the client's secret, which is the same name on here. The bottom two boxes you can leave blank, and you can just hit save now. Now we can add a application definition so we can protect it. So go to applications and click add an application. Self-hosted. The domain name is app.myBigBalls.space. And the subdomain is the same. This name can be anything though. You can also set the session duration here. This might as well be quite long. This is the amount of time between Cloudflare re-authenticating your users via Google again. So I'm going to set that to a month. You can leave the rest of this as default. You have to add in a error text. This is a little bit of text that we display to users if they are not on the allow list. And then you need to select some identity provider. So I'm going to untick accept all, and I'm just going to select my Google authentication that I just set up, and I'm going to turn on instant auth as well. So if you only have one identity provider selected, then it won't ask the user which one they would like to use. It will just immediately forward them straight to the login for that provider. So I'm going to hit next, and this is where we create a policy. So I'm just going to call this allow, and you can set up groups, which are useful if you want to constrain users. So I've done this here for some of the other applications that I've got. For this one, I'm just going to go to the create additional rules section. I'm going to select email, and I'm going to put in the email address of the Google account that I'm logged in as. I'm going to hit next. And I'm pretty sure all of this you can leave as default and then hit add application. And there you go, that is all you need to do. If we go back to this, we will then be sent to a Google sign-in. So I'm going to choose the Google account that I'm logged in as, and I get this confirmation here. And I'm talking to my web app again because I'm on the allowed list. And that's all you need to do. You can repeat this multiple times, so you can just add multiple applications here. Of course, you'll need to set up the tunnel first. So for each application, you'll want to go to Tunnels, select your tunnel, configure it, go to public host name, and then just add public host names. And it's here where you create the mapping between the public host name, i.e. the DNS entry for on your domain, and the location of the service on your home network. Then you'll need to go into access and add an application for each one so that you can protect it. If you did want to make something publicly available without any authentication, then you don't need to do the second bit. So you don't need to add the application. You just need to add the tunnel under networks. One thing that's worth mentioning is SSL, and this is pretty much automatic and free with Cloudflare. If you go to your domain from the home dashboard and go to SSL, scroll down to Edge certificates, you'll see that Cloudflare automatically generates an SSL certificate for that domain. You can also tick on always use HTTPS here, which will redirect any insecure requests to secure requests, and everything else you can just leave it default. And you'll see that the app is now served as secure, and you can see that there is a certificate in place that Cloudflare has automatically provisioned, which is really nice. The last thing that I'm going to cover is an optional step, but I really like this for to maximize your security. So as we've seen, Cloudflare Tunnel will allow ingress from the internet into any host on your local network, and we've configured it to be pointed at one particular service. And I didn't really like the idea of that. I didn't like it being able to talk to just anything. I only wanted it to be able to talk to stuff that I really trusted it with. And I thought, well, if someone compromised my Cloudflare account, then they could set up forwards to services that I didn't intend to be made publicly accessible, and it would be a very easy way into my network. So the way I've combated this is by setting up a firewall in Proxmox for the tunnel virtual machine. And I'm doing this at the Proxmox level rather than on the virtual machine itself, and just controlling what it can access. So to do this, you need to make sure that the firewall is enabled in Proxmox at the data center level, which is not by default. So if you select your data center and go to options and set the firewall to yes, and then on the virtual machine that you are running your tunnel on, go to hardware, select the network device and click edit and tick the firewall on. And the next bit I actually find easier to do from the command line. So if you're signed into your Proxmox as root, then you'll be able to select your node up here and use the shell option. I'm not, so I'm going to SSH into one of my hosts. I'm going to go to the folder where the firewall configurations are held, and I'm going to create a new firewall file with the VM ID of the virtual machine. So I'm going to write a Proxmox firewall configuration file now. It starts with options where we enable it, and then we add some rules. So I only really care about what goes out of this VM. I don't really care about what goes into it from the local network. So I'm just going to accept everything. So now I need to add some blanket rules for output for some vital services, DNS and DHCP. So I'm going to allow it access to local network, UDP 67 for DHCP, and very similar rule for DNS. And then I want to add any rules for the actual applications that I'm using this for. So we can add a very specific rule here. So that specific host IP address there, rather than a range, TCP port 9000. And then just some rules to mop everything up. So we want to drop any packets that haven't already been matched to. We'll be quite wide ranging on this. So anything that's on a private address space that we haven't already dealt with will now get blocked. And then we're just going to set a default one to accept any packets, allow any packets that haven't been specifically matched. So this is essentially just internet traffic. So we're going to allow DNS and DHCP on the local network. We're going to let it talk to that one application, and anything else we can assume will be internet traffic because we've blocked the private address space there. Obviously, if your network uses 10 or 172 or something like that, then you'll want to make up for that there. So yeah, we can write this to disk now. So I'm going to write that file. Heading back to Proxmox, I can select the firewall tab and just check that that all looks okay on this end. I can then jump back to the VM, and I'm going to verify that it can still talk to the application. And it can retrieve that. And I'm going to test this by trying to load a web page for something else that's available on my network. And we can see that that's just hanging there. Do one last test, which is to ping google.com, which involves a DNS lookup, and that's absolutely fine. So, as I said, that step isn't necessary for this, but it's just something that helps me sleep a little bit better, knowing that even if I had total compromise of this virtual machine, even to the operating system itself, it can't actually talk to the rest of my network apart from the applications that I've specifically allowed it to.